This is a module 7, investigation 7, shifts transformation of periodic functions. So, number 1, consider a function f shown in the given graph and looking for period, minimum value, maximum value, what is the equation, horizontal line, falls halfway between the function maximum minimum value, and what is the amplitude, define the function, formula for the functions. So first of all, period. Okay, so if you consider this function is a sine function, so I want to start from here. Okay, so up and twice up down and half above, isn't it? So about here. So this is the one period, and then about again, do it again. And that's another one, okay? So about here, so like a 4.2 something, right? So I want to say 4.2, it is about 4 pi over 3. Okay, and the minimum value, which is the lowest place, so which is this place. So this place, you can tell is a -7. And then maximum value is the highest place, which is here, so which is a 3. And then the function equals the middle line, so I'm going to cut that as half of the graph, which is about here, which is y equal to 2, -2. So half line is a y equal to -2. Amplitude from the half line to the maximum place or minimum place, how far it go up, how far it go down. So from here, 1, 2, 3, 4, 5. So amplitude is 5. So in order to find the formula, f of actually the x, amplitude 5, and then sine function, and then period is actually the 4 pi over 3. So in order to find the period is 2 pi over b. So period is 4 pi over 3. And then equal to 2 pi over b. And then look for b. It's going to be 4 pi b is equal to 6 pi. And divide by 6 pi both sides. 4 pi both sides, what am I saying? And then b equal to 3 over 2. So it's going to be 3 over 2x. And then the middle line is going to be -2. So that's the function graphs, okay? And then I'm going to do number 3. So number 3 is about the Ferris wheel again. So let's consider different scenario with the Ferris wheel, since the mathematical convention is to measure angle from the 3 o'clock position. We have typically had a rider on the Ferris wheel starting at 3 o'clock position, but what if we start from the different positions? So number 3, Shauna board the Ferris wheel from the bottom, which is 6 o'clock. So here, she's riding on here. Then what is the height of the ground in here? So when she was actually oh yeah, sorry about that. Shauna boarded the Ferris wheel shown from the bottom, which is 6 o'clock position, and the Ferris wheel rotate the counterclockwise, which is this directions. And after the Ferris wheel rotate the pi radian, so when she rides in here, and then she turn all the way to up here, okay? So what is her height? So height is from the here to here. So the radius is a 25, and then here to the ground is a 30. So 30 plus 25, which is gonna be the 25 feet. Oh no, sorry, 55 feet. So it's gonna be the 25 plus 30, which is 55 feet. And B, your classmate said that the expression 25 sine pi plus 30 should the calculation as a height above the ground after the Ferris wheel rotate the pi radian. So 25 sine pi plus 30, because they said that they turn in the pi radian, right? But sine pi is actually the 0. So which means this is only the 30, which is not the 55 feet. So that is not true, right? So nope. So in order to make the 55, what we need to do is she turned the pi radian from the negative pi over 2. So which is, if you call this is a 0, if you go to clockwise, this is actually the same as negative pi over 2 here. So which is, you got pi over 2. So instead of, if you put the 25 sine pi over 2 plus 30, that will become 55 because sine pi over 2 is 1. So 1 times 25 is 25 plus 30 is 55. So that's what we're going to figure it out in C. Okay, so after the face wheel rotated through each of the following rotation angle, what is Ochona's height above the ground? Write expression that represent her height using the sine function and then provide a decimal approximation of her height above the ground in feet. We recommend drawing a diagram of each situation first, okay? So now she was here, right? And then she turned the pi over 2, right? So which is, she had actually the pi over 2 to subtract the pi over 2, which is a 0 plate. This is a 0 degree, right? So she got the 25 sine 0 plus 30, which becomes a 30 feet. Now 2 pi radian, so which means she's starting from the negative pi over 2 and then go back to here. Yeah, that's the 2 pi radian rotations, right? So she goes back to the original place. So which is 2 pi subtract the pi over 2, which becomes a 3 pi over 2. So if you plug in 25 sine 3 pi over 2 plus 30, which becomes so sine 3 pi over 2 is a negative 1. So negative 1 times 25, negative 25 plus 30 is a 5 feet. Which is, that's a ground, right? Okay, 3 pi over 4 radian. So which is, now she turns in from the negative pi over 2, right? And then she only goes up to here. It's about here. About this. So what you do is, okay, 3 pi over 4, subtract the pi over 2, which becomes a pi over 4. So she got 25 sine pi over 4 plus 30, and then her place of 47.68 feet. And then 5 pi over 2 too. So what do you do? 5 pi over 4, subtract pi over 2, she got 3 pi over 4 location. So 25 sine 3 pi over 4 plus 30 makes the 47.68 feet. Now 3 pi over 2 place. 3 over 2 rotation, subtract from the pi over 2, which is going to be the pi, which is 25 sine pi plus 30. Sine pi is at 0, so it's going to be the 30 feet. Now pi over 4. So pi over 4, subtract the pi over 2. So she's still the negative pi over 4. Okay. Actually 3 pi over 4 radian is actually, oh no, she need to go this place. Sorry about that. And then you got 25 of sine negative pi over 4 plus 30, which is going to be the 12.32 feet. So we are going to sketch the graph of function that represents the Jonas height above the ground in the terms of the measure of the rotation's angle since she brought it. So in here, I want to say every 2 is pi over 2 pi, 3 pi over 2, 2 pi, 5 pi over 4, 3 pi, 7 pi over 2, and then 4 pi here. And then she went up to the 55, so I'm going to say everything is a 10, 20, 30, 40, 50, 60. Yep, I think that'll be enough, okay? So pi over 2, pi over a pi, and then the 3 pi over 2, and 2 pi, and 5 pi over 2, 3 pi, 7 pi over 2, and then 4 pi. Okay, so in the 0 degree, she was above actually the 2 feet above, right? So she was 2. Oh, 5, I'm sorry. So she was on the 5 feet, isn't it? So let's put the red. And then the pi over 2. And the pi over 2, she's on the 30. So pi over 2, she was 30. And then 2 pi was 5 feet. And then the 3 pi over 4. So 3 pi over 4 in the third quadrant, half of the third quadrant, which is 14.7 here. And then the 5 pi over 4 in the third quadrant, which is between the pi and 3 pi over 2, which is 47 over 8. And then 3 pi over 2, she was on the 30th. Okay. And then the pi over 4, she was on the 12th position here, right? So if you, and then when the pi was, she was on the 55, isn't it? So you got this. And then it repeat again, right? Right? So that's a graph. Is of course it goes this way too. So define the function formula for the function f. So this is a theta. So the middle point should be about 30 here, right? So it went up to the 30, 55, 25, right? So 25 amplitude sine up. But this time she actually the shifting to the pi over 2. And then midpoint is a 30, right? So that's how you write it for the sine functions. Okay? Alright, I think that'll be all. Okay, so thank you for listening.